In addition to splicing, eukaryotic mRNAs are further processed before they become mature mRNAs ready to be translated into polypeptides. They get a 5' cap and a 3' poly A tail. The 5' cap is a methylated guanosine nucleotide. This cap helps move mRNA out of the nucleus and into the cytoplasm. Near the 5' end of the mRNA is a sequence that recognizes an enzyme called poly A polymerase. That was the blue molecule shown here, which then binds and catalyzes the addition of several hundred adenosine nucleotides to the 3' end of the transcript. This poly A tail seems to govern how many times this message will be used to translate a polypeptide. In vitro translation experiments show that the poly A tail gets shorter and shorter the longer a solution of mRNAs is allowed to translate proteins. Here are some capping details. A capping enzyme brings a methylated guanosine nucleotide and an mRNA molecule head-to-head, as shown here, the check marks being the nucleotides. The enzyme then catalyzes a condensation reaction to form this phosphotriester linkage. In this illustration, the cap and poly A tail recruit binding proteins from the nucleus. One, shown here as a brown crescent, is a cap binding protein that binds to the 5' end of the messenger RNA. The cap protein, together with an RNA export factor, shown as the red square here, guide the messenger RNA out of the nucleus through a nuclear pore complex. Once the mRNA is out, the export factor comes off and can return to the nucleus, while a translation initiation factor displaces the cap binding protein. The cap binding protein probably goes back into the nucleus to be recycled as well, although that's not shown here. A poly A binding protein, the green oval in this slide, binds to the 3' end of the message while it's in the nucleus and then remains bound in the cytoplasm.